All right, this is the Algebra 1 Unit 5 review video. I'm going to go over the questions from our study guide and give you kind of everything you need to know for the test, types of questions you're going to see and things like that. So I'm going to jump right into working through these problems for you. Get this to work. It's not working. Try this again. There we go. All right. One thing you need to be able to do is identify the slope, y-intercept, and x-intercept of linear equations when you're given the graph. So just as a reminder, the y and x-intercept, this is what we call the y-intercept because it is where it crosses the y-axis. So our y-intercept is going to be 3, or you could put the point, 0, 3. The x-intercept is going to be down here, to where it crosses the x-axis. That's going to be the point -5, 0. And then to find the slope, you just need to count the rise and run from one point to the other. So you notice we have this kind of like box that we can make. So the graph goes up 1, 2, 3, up 3. That's going to be what we call the rise. And the run is going to be 1, 2, 3, 4, 5. The run is 5. So for my slope, I'm going to do the rise over the run, which in this case is 3 over 5. It's positive, we can see that, and so that's the answer for the slope. So that's pretty much how that's going to work. It's just simple finding the x and y intercept and then counting to find the slope. All right, let's keep moving. Then we have this information about transformations. We covered this pretty in depth in the unit, but just as some examples here, if I was looking at these and they want us to describe the transformation. So in some cases there'll be one, in some cases there'll be more than one. In fact, in the first problem, it's asking what is the transformation that's occurred when these things have been done to the original function, right? F of x is the original. So here we see there's a negative and there's a plus 3. So the negative tells me first that the graph is reflected on the x-axis. And then the plus 3 tells me that we're going to be shift up 3 units. So that's what this tells me. Let's just make that clear. That tells me that, and that tells me that. The next one, we just have the plus 4, but now it's on the inside. So that plus 4 tells me that we are going to shift to the left 4 units. You just need to go back and look at the information on the lecture notes. If you're having trouble with these, all of this is spelled out there. And then on the last one, we have a 4 being multiplied, and that's going to be what we call dilation or a stretch by a factor of 4. That's what that tells me. All right. So make sure you review transformations. And then it wants us to match those with these different graphs. Okay, so we need to find the graph that's been reflected and shifted up 3 units. So let's jump over here and see. Well, for a reflection, we know that it means the graph is going to be going down instead of going up. So the middle graph would be an example of graph A, or g of x. So let me do that. It's going to be, middle one is going to be g of x right here. Okay, and then look, going back over to the other one. This next one is going to be shifted to the left 4 units. No change in the slope or anything like that. So that's going to be down here. That's going to be h of x. And then the last one is stretched by a factor of 4. So that means, I think that one is k of x right there. So you can see the reason I know g of x is this one is because since it was reflected, the blue graph now goes downward, and all of these, the blue is the resulting graph, the red is the original graph. So we see in g of x, we have a reflection downward, and we have a shift up. In h of x, we have a shift to the right, or to the left, sorry. And then in k of x, we have a dilation or a stretching upward. And so that's how that one comes into play. All right, let's look at our next one. Find the equation that is parallel to the line y equals 2x plus 3. That's some key information. And passes through the point 3, 2. So the formula we'll need for this, and I will post that on I think it is on the lecture notes, but I'll make another version of the different formulas you're going to need. We know that if it's parallel, that means the slopes are the same. So we already know that the slope of the line is 2, and that's coming from right here. So that's one piece of information we already know. And we also have a point. So when we have the point and a slope, we can use the point-slope equation, which is y minus y1 equals m times x minus x1. So when I do that with what I have here, I get y minus y1, which is 2, equals, and then my slope is 2, parentheses, x minus x1, which is 3, and then I work this out. So I get y minus 2 equals 2x minus 6 because I distribute the 2, and then the last thing I do is add 2 to both sides. So the final answer is y equals 2x minus 4. I'm just going to move all of this up if I can. There we go. And that's what my final answer is for number 3. Similar idea here in number 4. We have a line that's perpendicular, key piece of information there, and we're given a point. So to find a line perpendicular to the line, we take the original slope, which is negative 1 over 3, and we make the opposite and the reciprocal. So to do that, we change it from negative to positive, and we switch the fraction to 3 over 1. So then 3 is the slope of my new line. So again, we're going to use the point-slope formula. The point-slope formula for this one is going to be y minus y1, which is 2, it's coming from right there, equals 3, parentheses, x minus 1, which is x1, and then we work it out. So we'll go through y minus 2 equals 3x minus 3. Let's bring that up here. And then we're going to add 2 to both sides, giving me y equals 3x minus 1. And then that's the end of that problem. So just notice when it's parallel, use the same slope. When it's perpendicular, you need to do the opposite and the reciprocal, which is what I did right there. More of the same. Find the x-intercept of the line with the slope of 3, passing through the point negative 2, comma 3. Okay, so we're gonna find the equation of this line, and then we're going to graph it, and then we're gonna find the x-intercept that way. Remember, the x-intercept is talking about the where it crosses the x-axis. So we have a slope of 3. That's m equals 3, and we have a point. So we're gonna do the point-slope formula. Y minus y1 is 3 equals 3, which is the slope. X minus negative 2. We'll deal with that in a second. So we work it out. Y minus 3 equals 3x. That's going to be plus 2, so it's going to be plus 6 when we multiply the 3 by everything. Let's go and bring this up here. We get y minus 3 equals 3x minus 6, plus 6, sorry, plus 3 to both sides. Let me do a different color on that. Plus 3, y equals 3x plus 9. So we're going to go find the x-intercept of that line. So we're going to jump over to our graphing calculator, and we're going to do y equals, oops, let's do this without that. How about that? Y equals 3x plus 9. Let's make sure I did that right. 3x plus 9. All right, let's make this go down, and we'll see where our x-intercept is right there. The x-intercept is -3, so that is our answer. Run over here, and so then our x-intercept is -3, 0. Let's write that down here. X-intercept is -3, 0. So that's from the graph. So graph. So you just find the equation and then you graph. Next one, find the equation and line passing through the points -4, 2, and 2, 5. So first things first, we're going to use the slope formula, which is y2 minus y1 divided by x2 minus x1. So y2 is 5, that's here. y2, y1 minus 2, x2 is 2 minus -4. So we get 5 minus 2 is 3. 2 minus -4 is 6. That simplifies to 1/2. That's my slope. And then I can use either point to get the answer. Doesn't really matter. I'll go ahead and use the second point, 2, 5. So we're going to get y minus 5 equals 1/2 x minus 2. Y minus 5 equals, and we're going to distribute 1/2. 1/2 x minus 1. 1/2 times 2 is 1. Bring this up here. Y minus 5 equals 1/2 x minus 1. We're going to add 5 to both sides. And the final answer is y equals, sorry, bled off the page a little bit there. Let's get that back in there. Y equals 1/2 x plus 4. And then that's the end of that. All you do is find the equation. Next one, which equation standard form matches the graph? So you have 3 standard form equations. In order to find if they match the graph, I think the easiest way is to put them each into the y equals mx plus b form. So we'll start with answer choice A, which was 5x plus 2y equals 10. So we're going to do the process, which is to first move the x, and then 2 divide by the y. So I'm going to move x first. I get 2y equals -5x plus 10. I'm going to divide both sides by 2. Y equals -5 over 2x plus 5. You can already see that the y-intercept is not correct because the y-intercept here is -2. That doesn't work. So A cannot be the answer. So we go to the next one. We go to B. B is 2x plus 5y equals 4. All right. So we minus 2x from both sides. 5y equals -2x plus 4. You can already see it's not going to work out because 4 divided by 5, that's not even going to be a whole number. So already I know B is not the answer. So C has to be it. If you want, go ahead and work that one out just to verify, but C is going to be our answer on that one. So use process of elimination if necessary. This one's pretty simple. Which graph shows the linear function? Well, a couple things. We see we have a negative slope that automatically eliminates these answers, but also we see that the y-intercept is 3. So that means this one is my correct graph. Okay, now we get to questions about correlation and linear regression. So we're going to use the Desmos. Use Desmos. You need to make sure you have that graph system handy. So we're going to go to our linear functions one, and we're gonna do what we call regression. You remember this from the lesson. We're going to enter all the data from our table here, 43.99. Go here, 43.99. I'm going to just enter all this in here. 21 and 65. 25 and 79. $42 and $75. $57 and $87. And lastly, $59 and $81. Well, you can't see the graph, but that's not really what matters. You need to find the R value. So we see here the R value, is right here, 0.5298. So we'll stop over here. Correlation coefficient, 0.5298. Is it very strong, moderate, or very weak? Moderate, anything near 0.5 is going to be considered moderate. Strong is going to be everything from there up to 0.9, and anything above 0.9 is going to be very strong. So moderate is anything kind of in the 0.5 area. So that's pretty much it on that one. Now on the next one, it's a little bit different. We have to do actual regression. So we're going to go here, and we're going to enter this into the correlation. But one thing I want to say for sure to do is to change these to 1, 2, 3, 4, and 5, just so it's a little bit easier to deal with. So we're going to do 1, 2, 3, 4, and 5. Let's clear our graph. There we go. And then let's go up here. We're going to do 1, 2, 3, 4, 5. We're going to get rid of this last row. And then over here, we're going to put the values from the other part of the table. 110, 123, 138, 150, and 168. We have our graph. You can see it kind of goes off a little bit, but now if we zoom out, we can see our points. We see that has high correlation. And then we have our parameters for M and B. And this is kind of the key piece that we're looking for. So that's my M and my B. So I'm going to hop over here, and we're going to write the equation that we got. So it's y equals 14.3 x plus 94.9. Then they want us to know, what about 2024? Well, 2020 was 5, so 2021 would be 6, 2022 would be 7, 2023 would be 8, so 2024 would be 9. So we're going to use 9 here. So we hop over to our graph, and we can use our trace function to find where the 9 is. There, when I went by it there for a second. Or you can go down here and you can type x equals 9. And then that point right there will tell you the value for 9. So all I did was take and put in x equals 9 and find the intersection between my line and that point. So it's 223.6. So we'll round up to 224. So we think there's going to be 224 students if it continues to grow at that rate. All right. So besides that, there's some vocabulary on the test. Make sure you look at the review for that. But besides that, that is all for this unit test, and hopefully that is going to be helpful to you. I will post the answers as well on the class page. And that is it.